Emergency management, a multifaceted system designed to handle hazard risks and disastrous events, is essential for upholding community safety nationwide. Its main objectives focus on preventing injuries, saving lives, and protecting property and the environment amidst emergency events. This is quite a daunting task, especially when considering the wide scope of disasters that could potentially arise: natural events, technological hazards, CBRN incidents, and even terrorist or cyber attacks. Emergency management personnel must be able to utilize reliable tools to assist them in effectively accomplishing the mitigation of, preparation for, response to, and recovery from this extensive list of arising catastrophes. This is where technology comes in. Technology plays a crucial role in emergency management and has revolutionized the field. It has led to the implementation of more proactive mitigation measures to reduce the likelihood of disaster occurrence, as well as the creation of disaster simulation exercises to aid in safe personnel training. New technologies produce more efficient and coordinated response operations, while also helping to speed up the restoration of services in the recovery process. Technological advancements have enhanced emergency management personnel's proactiveness in decreasing the likelihood of disaster occurrences. Risk assessment automation. New technology has allowed for the automation of important steps in risk assessments. This includes new tools that continuously monitor processes and flag potential risks, streamlined compliance checks and generation of reports, as well as detailed audited trails. Building code software. Technological advancements, including artificial intelligence and building information modeling, have significantly aided in the development and enforcement of building codes. The integration of these tools has created new code, plan, and permit softwares that ensure more effective and accurate compliance. Advancements in technology have assisted in the preparedness phase, leading to enhanced personnel training practices and increased situational awareness. Virtual reality and augmented reality can simulate various disaster scenarios and training exercises, allowing responders to improve their readiness, decision-making, and response to these situations without being exposed to the risk. One program that implements these technologies is EDGE, a free virtual training platform used by first responders and educational institutions to prepare for a response to critical incidents, including active shooting situations. Predictive models provide a better understanding of how an emergency or disaster will impact an area, allowing officials to create early action plans. Advanced technologies, including AI and machine learning, integrate historical data with real-time monitoring information to predict and detect natural threats, as well as pinpoint the regions at risk. Early warning systems utilize real-time data from satellites and sensors to predict natural disaster onset. They issue timely alerts that allow authorities to carry out preventative action, including initiating evacuation plans and allocating resources. These systems also disseminate information to the public. One example of this is FEMA's IPAWS system. Technology plays an important role in emergency response activities, enabling more efficient and coordinated action, more accurate situational assessments, and enhanced communication. GIS systems integrate data from various sources, including satellite imagery and remote sensing networks, and overlay it with geospatial information. This leads to enhanced damage assessment, identification of affected areas and their corresponding populations, and resource allocation. Robotics and drones have revolutionized disaster response operations. Drones equipped with cameras, sensors, and communication systems can quickly survey affected areas and assess damage, identify survivors, and deliver essential supplies. The invention of robots that possess search and rescue capabilities assist responders in locating and saving survivors in hazardous environments. New technologies such as real-time messaging platforms and video conferencing applications enhance communication between response teams and agencies. They enable the timely sharing of critical information, including evacuation plans, situation maps, and resource locations. This leads to more coordinated response operations. The creation of innovative technologies that aid in the restoration of affected essential services, communities, and infrastructures have led to more efficient and effective recovery operations. Smart grid technologies are able to detect faults, isolate damaged sections, and reroute power in energy distribution networks. This minimizes utility downtime and ensures critical facilities have a reliable energy supply. Energy management systems optimize energy usage and efficiency. They also integrate renewable energy sources into the recovery process. 3D printing can develop the necessary replacement components for damaged infrastructure, create temporary shelters, and produce medical supplies and equipment for affected areas of a disaster. BIM enables the creation of detailed digital models of buildings, infrastructures, and utilities, as well as information about the materials necessary for construction. It assists with restoring damaged structures by providing accurate documentation, estimating repair costs, and coordinating planning between stakeholders.